So now it's time for our first activity. And you will literally be having your taste buds tickled. Easy to say for you, but not with my teeth. So I've been told you only need simple things like milk. I'm lactose intolerant, so I've got some lovely Oatly stuff, a little bit of sugar, something sweet, vanilla essence, and some salt and a plastic bag. I've been told and reassured that from this we're going to be able to make something from our chemistry kitchen. It is going to be wonderful. Can I please introduce you to Sheila Sweet Salt from the Salters Company? Sheila, how are you doing?
Hi Fayon, thank you so much for having us, and thank you to the virtual Sutton Science Festival. It's so exciting. I mean, it's a real first for us, but we're really excited. And can I just say, here in sunny Southampton, it is absolutely boiling. It's the perfect day to make ice cream.
Ooh, well look, I'm all ready. I'm all summery ready. I thought, should I wear a jumper? No, we're going to be making ice cream. Let's make it cool.
Perfect.
So can you tell me then, this idea of making ice cream from such simple things in your kitchen cupboard, where did this all stem from?
Well, that's a really good question, Fayon. We use a secret ingredient that is found in so many chemical reactions, but actually you kind of need to reverse back in history. You need to do a bit of time traveling because the Salters Company is a livery company. Now, that's a really weird word. Do you want to take a guess? Does anyone at home want to ask the person next to them? Maybe put it in the chat. What do you think a livery company is, Fayon?
Well, I have a good idea actually what one is. I'm wondering if anybody out there knows. Quick fingers on the pulse. No? Okay, you tell me.
Okay, perfect. So livery companies were set up in medieval times. We're more than 600 years old, and we're based in the city of London, and we act as sort of trade unions. So think if the fishmongers, they traded in fish, the goldsmiths traded in gold. Fayon, if we're called the Salters Company, please tell me, what do we trade in?
Salt.
Got it. Excellent. I'm so pleased you got that right. I hope everyone at home at school did as well. So we traded in salt. And back in the medieval times, the reason that salt was so important is because it acted as a preservative, because they didn't have things like fridges or freezers. They didn't have any electricity. So they needed this salt to draw out all the bad bacteria, the moisture, so that the food would last over the winter months. And even today, salt is used in so many chemical reactions, and that is what we're going to be doing today. That's where it all stems from.
Wow. I mean, if you look at most food, no matter what it is, there's salt in it, the sweetest of things.
I know, it's amazing.
So I can't wait to see this in action. And of course, the students who are watching today, you're going to be able to watch this video over and over, and you'll be able to make your own ice cream with whatever flavors and toppings that you like. So let's just see how easy it is to make, because I mean, if you're not that brilliant at science, is that going to be a problem?
Fayon, it's not going to be a problem at all. Let me tell you, my background is not science, it's not chemistry. I've learned it and I've taught myself that, and it's really fun, which is what the best bit is. Like, my background is history and art, but it's not science and chemistry. But because it's so fun and it's so accessible, and you can just have a go and you can keep trying it, it doesn't matter if it doesn't work the first time. It's really simple.
Cool. Most great things that are around us all the time didn't come off from the first time that they were tried, many, many, many times over. So with this one, I think you're going to have a lot of fun trying it over and over and getting it wrong.
Yeah. You just get to eat ice cream over and over again. It's brilliant.
This be. Okay then, well, off you go.
Okay, so I thought what we'd do is, first of all, we'd go through what you needed. You briefly showed before, but also for anyone at home, you might have the the instructions and the methods here. So we're just going to go through and I can show you the kind of things you need. And the amazing thing about this experiment is that everything is pretty much in your kitchen, and it's stuff that you'll know that's in the back of the cupboard, wedged right at the back, and it's been there for years and you won't know. So you've got salt. Very important. We've got caster sugar. This is really important that it's caster, not granulated. You've got some vanilla essence, but what's so exciting is that you could try any other different flavors or toppings. Some lovely milk here. And we've got ice as well. Nice bag of ice there. And you're going to need a small zip seal bag and a large zip seal bag. Now, if I can just recommend a little top tip here, always try and get the ones that have got the zip seal, because sometimes when you're doing it, it'll pop out and it's like a crisp packet. It can just explode everywhere. So those, so those are everything you're going to need, and just some tablespoons and teaspoons for measuring things out. But like I said, it's all really simple. It's stuff that you can find in your kitchen. It's really accessible. So should we get started?
Please.
Okay, so if you've got your worksheet in front of you, it's on the instructions for making ice cream. So you're going to need your measuring jug, and you are going to measure out 150 milligrams of milk. So let's just measure this out like this. So you've got your 150 ml of milk. Now, I use full fat because it's the particles that you need to all come together. So I haven't tried it with your, what did you say it was?
I was going to say, so I'm lactose intolerant, so I've got like an oat one, but you know, we've got like the almond one that we have, we've got the chocolate one, we've got all the flavours. So does that mean the consistency isn't going to be quite as good?
Well, I mean, like I said, I haven't tried that, but I think that's what's really exciting about this experiment, is that you can try it. And the consistency, I think, with coconut milk, it might be fine. I think with hemp milk as well, you could try that. But give it a go, Fail.
Goat's milk.
Oats milk, and you can try goat. Oh, goat, yeah, try goat. Give it a go. I love all this random milk that you're bringing me. And you're going to go for a teaspoon of sugar. Now, I have to tell you guys at home, this is my confession. I have got such a sweet tooth, so I put in quite a generous size thing of a teaspoon of milk. And then
things I was just going to say with this, brush your teeth after and do make sure you ask your parents permission as you start going through the whole cupboard, because you can imagine mum and dad going to make their coffee and there's no sugar left.
Oh yeah, that wouldn't go down well. That wouldn't go down well. And like I said, I'm always very generous with my portions, but you want to make sure as well that you stir it in quite well, because otherwise it all gets stuck to the bottom and you don't get it as sweet, and you need it for your sweet salt. So you are going to open up your small zip seal bag like this, nice and open, and you are going to very carefully pour your milk in. Now you might need a bit of teamwork. I'm going to give a go doing it by myself. Let's see how it goes. Off camera, here we go. It's all going well so far, guys. Excellent, see?
Oh, well done.
In there. Now, another top tip is that you're going to want to get all the air out. So if you crush it all out, and you're going to do it up, and you're going to place that to the side for a second. Now, this is where it gets really exciting. This is where you guys at home and at school and Fayon, you're going to become the chemists and scientists, and you're going to work as a team and you're going to investigate, because the Salters Company got a little bit sneaky. We told you how much milk you need, and we told you how much vanilla essence, but we didn't tell you how much ice you're going to need.
Ooh.
Or how much salt you're going to need. So because I'm not actually going to do the part with you, the actual making part with you, I'm going to give you a top tip and another kind of helpful hint. So for the ice, so you've got your large zip seal bag here, and I would put in a good quantity of ice to get started. So you'll see me putting it in here. So there's some ice.
Think party. Think, you know, you're having a party.
Exactly.
Nice and cool. So plenty of ice.
That's it. You want to put in a really nice, generous amount. You see, I'm still going with it. Still going.
I mean, when you think about, you know, brain freeze when you have ice cream and it's just like, this is how cold it needs to be.
This is exactly how cold it needs to be. Okay, now So this is that's my starting amount of ice. Bayon, can you see everyone?
I can see that.
All good? Okay, excellent. And then this is the salt, okay? So again, haven't told you, but if you've thought about it before your experiment and you're working as a team, maybe you could do a hypothesis, a prediction of what you think is going to happen and what do you think the salt's going to do. Now, again, sneaky little top tip here, guys, for you. Look how much salt I've poured out into this. I know, it's quite shocking. Yeah, I know. So I'm going to start with maybe 1 tablespoon. Here we go. And you pour it into the large zip seal bag with the ice. And just for good measure, because it is the Sutton Festival and we've worked hard to get here, so I put in 2 things of ice. Now, first of all, what you want to do is you want to make sure that the salt is really touching the ice. And then, remember this bag? Okay, so you want to put the milk mixture in with that ice and the salt, okay? And again, you want to get out all the air like this, okay? So it should be like this. Now, this is where I would recommend a tea towel, because what you're going to do is you're going to turn it and turn it, and you're going to keep turning it, okay? So you just want to make sure that the milk mixture is always touching the salt water, okay? That's really, really important. Mm-hmm. And you're going to turn it for, say, about 10 to 15 minutes.
So this is like the churning effect then?
Exactly, yeah. It's just that, Fayon. It's just like the churning effect. Mm. Now, we want the temperature of that salt ice water to drop below 0. So okay. I've got myself a thermometer here. Now, you might not have it at home. You could use one that's used for cooking, or they're really cheap and you can buy them off Amazon, or if you're in school, you'll probably have one in your lab. Now, what I think, if you want to do it like a proper investigation and have some fun with it, is you're going to pop your thermometer, open up the zip seal bag, and you're going to want to pop the thermometer in. So can you see there? Yeah. It's touching the ice water.
Yeah, I can see that.
And you need that temperature to start dropping, and you want it to get well below 0. Wow. Okay, so I'm going to leave this to the side a second. And
can I just say, we've got so many more people who've come into the presentation. Hi guys, good to see you. This is Sheila. We're making ice cream. If you've got any questions at all, please ask. You don't have to be a scientist. These things are in your kitchen cupboard that she's using to make this ice cream. So yeah, just please send your questions if you've got any.
Perfect. And like I said, so I'm just leaving that there for the second, but like I said, you'll have one of these worksheets as well. So you can do the investigation yourself, you can do the experiment. You've got, it says starting temperature, and then we recommend recording every 3 minutes or so, just to get a feel for it. And then there's a bit where you can present your findings and record your findings as well. So you can do it like a proper experiment. Now, obviously, we're not going to be here 15 minutes turning together, so I think it might be time, Fayon.
Is it time? Oh my gosh, we've got loads of questions coming.
Wow.
Keep going.
Okay. Well, I feel like, so you're going to have turned this for 15 minutes or so, and I can already see that even just being sat next to the icy water, that this is starting the ice cream, the milk is starting to solidify even in the ice. Can you see that?
Yeah.
Amazing, isn't it? Now, do you think it's the reveal time, Fayon?
I'm going to get my fan.
I want to hear a drum roll, Fayon. Let's have a drum roll.
Everybody, I know that we cannot see you, but wherever you are, make some noise. Bang the desk, stamp your feet, make some noise. In 3, 2, 1. Ice cream.
I know, here it is. It's like a Blue Peter. Here's one I made earlier. So, can you see? This is amazing, isn't it? And this, no refrigeration, no electricity. Everything was just done using salt. It's incredible, isn't it?
I'm just going to say the chat is alive right here, right now. People are going, wow, that looks great. That looks awesome. Yeet, yeet, yeet. I love that. Also coming. A lot of chat.
A lot of chat. So now, as you can see, it is going to be like it's more like a Mr. Whippy. I would go for like that Mr. Whippy consistency, but I don't know about you, Fayon. I love a Mr. Whippy.
I do, as long as I can have the lactose thing, you know, with a flake, and I like colour. I like the squeezy strawberry stuff, the flavouring on there as well.
Excellent. Now, Fayon, do you mind if I try a bit?
Please try some.
Now, because this is the best part of the experiment, guys. So once you make it, it's all about the tasting. Okay, so here we go. Oh, it is good. It's so tasty.
What does it taste like?
You can really get the vanilla.
Okay.
It's really good. And it's really creamy because you've got that milk. And it's like really soft and creamy. It's not, like I said, it's not hard. You don't actually get brain freeze, which is excellent.
It looks yummy. Thanks, Azra.
It is. I mean, it's a good thing I'm on screen. Otherwise, I would just keep eating this. So good.
Oh, gosh. I mean, I'm just thinking to myself, right then, I just want to go for maybe chocolate. I might chocolate.
Mm-hmm.
I might, what if I put in like frozen fruit? Can I do that, do you think?
I think give it a go, because this is what's so exciting about this experiment, is that next time you do it, you can change. Like, I've gone for the vanilla essence, but you can try a chocolate one, a strawberry one. You can maybe put chopped chips in, see how it freezes and solidifies around that, see what happens to it.
My gosh. So this is the thing, guys, there is no holds barred on this one. I mean, I don't have extreme tastes, I don't think, but I bet you guys do. I mean, at the moment, I'm just thinking about fruit, but do send in the Q&A chat facility any questions that you have for Sheila. Remember, there is a history to this. This goes back to medieval times, you know, when they didn't have refrigeration systems. They came up with this. I mean, you know, is there an idea that you have for how you can sort of keep things cool? Or do you have any recipe ideas? Send them in on the chat. But you did say at the beginning that, you know, you're not a scientist, you don't have a science background, but there is a science to this, isn't there?
Oh my goodness, there really is. And even though that was a really, really simple experiment, there's actually so much going on behind the scenes there. So, for example, if you were thinking about it at school or at home and you're thinking, what is happening in this experiment? Well, just to name a couple, and you can do your own research at home when you're trying again, but there's changes to the states of matter. So you know how we had the solid ice? Well, the solid ice melted and became that kind of salty water. And then the liquid milk mixture actually froze into a solid. So you had those changes of states of matter, and you had energy being transferred back and forth. It's an endothermic and an exothermic reaction. It's really exciting. But I think the most important thing that people need to take away from this, and Fayon, I hope you remember it, is that it's salt. The salt is the key ingredient, because the salt is like this, has magical powers, and it can lower the freezing temperature. It makes it so cold, that icy water, that it draws the heat out of that milk mixture. It freezes everything around it so that the milk becomes a solid. And I think that's incredible.
That is absolutely incredible. You just blipped out for me just for a second there, but I hope it wasn't for anybody else. So thank you. Now, company, I've got some questions. Thank you. Gurik Garawal, thank you. Sorry for any pronunciation problems here. Asks, has your company always worked with salt?
Oh, that's a very good question. We actually have always worked with salt. We, like I said, we started as a kind of trading company, and our first hall, we've had 7 halls. Our first hall was actually in Bread Street in the City of London, because we used to trade salt to the bakers, and then they would put it in their loaves of bread as a preservative. And then we just always continued to trade. We don't do it so much anymore, but now we are more of a charity, and we do lots of education things. So we run family workshops, school events, tours as well, but always kind of focusing on the kind of chemistry and science side behind salt.
Fantastic. Somebody was asking, maybe they haven't received the worksheet, they were asking where you can get the recipe from.
Yeah, so if you can't access the worksheet or you don't have it with you, you can go onto our website, salters.co.uk, and if you go into company, public programmes, you can get one of the worksheets there, and it tells you the instructions, the method, and there's a little bit of history as well. I would really check it out. It's really, really amazing.
Brilliant. And can you just confirm again what type of sugar, please? Luke Fordham was just asking.
Mm-hmm. Okay, so I would go for caster sugar, just because it's a bit thinner. So you could try granulated, but we've always tried it with caster sugar. People who might want an alternative could try things like coconut sugar. And I would love to hear what you tried. So always feel free to send us a picture, email salters@co.uk, and we would love to hear what kind of recipes you've come up with, what different alternatives. Share.
That's it. And people are asking again, you know, about the milk quantities, 150 mils, is it more, is it less? Mm-hmm. From what you're saying, start with a little, maybe start with 150 mils and then increase or decrease, it's up to you.
Exactly. I mean, you are in control of this experiment, which is what's so incredible, is that you can decide. You can make yourself a whole ice cream production line if you'd like. And now, we're all having to stay home a bit more, but the summer's here. You can make your own ice cream.
Absolutely, you can make your own. And is it Indira? Indira and Christian is saying, can someone help? Now, I don't know if that's helping with your internet to create creation here, because you've got a few problems I can see. But if you're asking for can somebody else help you, then please get somebody else to help you in on this. Vidang Pandit is saying, can you freeze it?
Well, I mean, you can freeze it, but the whole amazing thing about this experiment is that you don't need a fridge or a freezer. But if you wanted it to last, how you might get a tub of ice cream and then you put it in the freezer, you could always put your milk mixture, once it's solidified, in the freezer and keep it. And then you've got your ready-made ice cream for next time you've got people over or you want some ice cream on that hot sunny day.
That's the one. You see, now here come all the questions. I like this one. What is it in the salt that makes it so useful? That's from Kevy P.
Well, that's the salt that lowers the temperature of the ice so much that it's going to draw the heat away. It's that energy transfer, and it's drawing the heat away from the milk. So it's the fact that the salt can make it so cold and draw the heat away from the milk mixture.
That's it. And it's a case of you guys obviously doing this at home. So do ask for your parents' permission before you start raiding the shelves and they're like, where's the milk? Where's the sugar? You're going to have to go to the shop. So please do that. I'm just double checking any more questions before we go. Oh, how do we get the recording of this session? Yeah, this recording is going to come via our website. So keep your eyes on the successful Sutton bid website. I'll give more details of that in a moment. Oh, somebody's asking, about an ice cream maker. Where's that one gone? I like that. Where's it gone? Oh, there was a question about an ice cream maker. I think somebody's trying to take a shortcut.
No, give it a go.
Could you?
I mean, you could try. I mean, I haven't used an ice cream maker. I've always done it this way. But yeah, again, give it a go. Let us know.
And this question came through a little bit earlier, so I hope it's been answered for you now. They were asking, how does it link into science? And I think you gave some examples already. So that's that. People are asking for the worksheets, so you can get those online. And how much sugar, how much vanilla essence, we've covered that. And the reason everybody cannot see this yourselves on screen is because there's about 400 of us, 100 of you, and it's all about GBT as well. So we've got to protect you guys. So we can't have you guys seen on screen, but you can see us, of course. Just last couple of questions. Do you have to do the experiment if you don't have the ingredients? All right, I understand. So that's coming a little bit late. I think that's all the questions. Oh, hello. Oh, somebody's asking if salt is sodium chloride, right?
Yes. Yeah, it is sodium chloride, NaCl.
Okay, fantastic stuff. Okay, I think we've had all the questions. People still asking, for the script. You can get this. I'm going to tell you exactly where in a moment. How many different flavors can you make? How much time have you got?
Exactly. Go crazy.
Okay. Oh, somebody's asking who invented ice cream.
Oh, that's a very good question. I know that the first person in England to try it was Charles I, but also the Romans were eating it as well. It's got an amazing history.
You see, and somebody was asking, who was that asking about where they get ice cream from in medieval times? Who was that? I just saw that flick through. Well, look, the Romans, they invented roads, they did everything else. So the last question, what other things can you freeze using this technique?
Oh, that's a very good question. I mean, you could try things like liquid. I mean, if you think you can make ice lollies with fruit juice and then you put the stick in the butt. So really, it's endless. It's how much you want to try.
Okay, good. And Sebastian, I like this man. I like the cut of his jib. He's saying, this is Sebastian Sorisco. On a scale of 1 to 10, how good is it?
Definitely a 10. It's got to be a 10. Because also it's homemade. I mean, I know I'm biased, but as soon as I go off this, I'm going to finish off the rest of my ice cream, Fayon, and everyone. I'm being honest, I'm going to finish my ice cream.
Woody Melbourne, last question, because other people might be wanting to know this. It's the last question. Where does salt come from?
Oh, that's good. Well, you can there's two ways that you can get salt, and one is from the sea, so it's from evaporation. They used to have these huge salt pans that they would leave on the side of the water in the sea, and then the sun would evaporate, leaving the salt brine. So that's one way, evaporation. And another way is through mining. So you can drill right down into these salt mines and they kind of get scraped off. And it's actually something that still happens today. We've got some in the UK, some in Cheshire, and we've got at the Salters Hall actually this amazing salt statue. It's absolutely huge, kind of like almost life-size, from a rock salt mine in Cheshire. So the two ways are mining and evaporation.
Brilliant. And on the chat, people are actually asking and answering the questions for you. So thanks, guys, for getting so involved. There's one last question. Honestly, they've come in, they've just gone long. It's the last and final question. Somebody just wants to know, from start to finish, how long does the process take?
Oh, good question. Start to finish, I think it would take, from measuring out your ingredients to turning it and churning it, I would say about 20-25 minutes.
Excellent. Thank you. So I feel we could go on so much longer, Sheila, but we're going to have to get on to our next guest, but it's been wonderful to speak to you.
Thank you so much.
Everybody here, thank you so much for your participation. If you have a look at Enjoy Sutton on Facebook, we have basically got our big show on the 18th of July. It's for all age groups. There's everything there. We've got so much, and I'm going to talk about that a little bit later. But do you just want to give your website details one more time where people can access this information before you go?
Yep, so it's www.salters.co.uk. And again, Theon, and to the virtual Sutton Science Festival, I just want to say a massive thank you. It's great to be part of it. I hope everyone at home has some really good fun. And I can't wait to see what the other guys have to bring.
Brilliant. Thanks again, Sheila. Thank you so much. Wow, gosh, we're off to a great start on this virtual science festival. So thank you so much for being part of it. So we are now looking at something very illuminating. Now, with engineering and electronics, this is the area we're going to go into now. I think you'll agree with me that, you can pretty much, find, that everything is controlled electronically or run by electricity. So, there's plenty of interesting and well-paid jobs out there for you if that's the area that you're thinking about going into. Now, computer programming is relatively easy and it's very interesting. If you've never tried it, you're going to get the opportunity to do so later on. And I had a little go myself using this equipment. It's called Scratch, and I'm very pleased to introduce you to Mr. Moonlander himself. It's Robert. Hi, Robert. How you doing?
Hi, Faye. I'm doing fine. Thanks very much. And welcome to Moonlander.
Yeah, great to have you here.
I like the look of the ice cream. I hope she has some left over. Well, the aim of this activity is to have a bit of fun programming a Moonlander. I'm an electrical engineer. I'm sorry I can't be with you today, but that's because of the coronavirus and so on. So we're going to do some programming. So don't worry if you can't complete everything on time, because you'll be able to download the program and also the details of how to do it from the website later on. But if you need to, while I'm just talking about electrical engineering, how about logging into https://.scratch.mit.edu.
Right.
Your computer set up.
Robert, I think we'll pop that link into the chat in case people don't have it.
Great.
My able assistant, Julie, to pop that into the chat so people can log on in case they don't have it.
Right, I'm going to share my screen now. So we're going to go over to Moonlander screen. I hope. Share.
Here we go.
There we go. Can you see that okay?
Yes, thank you.
Great. Okay, so what we're going to program is how to land your rocket ship on the moon. But before that, I'm going to talk about, if I can get this thing to go forward. Dear, dear, got a technical problem here.
Here
we go.
There's going to be.
We're going to have a quick look at the many different types of jobs that engineers can do. And I was saying earlier, get set up with your computer ready to start programming by typing in this URL here. Right, there are lots of different types of jobs you can do, and one of them is to work in research and development. So in that case, you'll be working in a design lab, designing new products, or you might be trying to make new discoveries. And of course, electrical engineering covers a massive range of different industries and organizations, from universities to the biggest companies to the smallest companies. And you could be working on anything from the latest iPhones to a new tablet computer, or you could be working in transport. Electrical transport, almost all cars now are controlled by computers. And there's a huge industry in the power industry, of course. And the nice thing is you get lots of opportunities to travel around the world. So you can travel the world and get paid for it, so to speak.
Nice.
other areas, there are lots of different areas which you can work in within electrical engineering inside one particular company. So you become the company, you could work in installation and commissioning, that is going out to the client's sites and setting up the equipment, or advising the customers on what they should do, or fixing the equipment if it's got problems. And that way you learn management skills, you learn leadership skills to organize other people, and you learn about the company's products. So it's a good way to get promotion in the future.
And can I say, Robert, you know, when I go into schools and sort of do motivational workshops and stuff like that. And I always ask young people, you know, what do you think some of the top skills are that employers are looking for? And they say skills like the qualification, and networking and working in a team and being able to think outside the box. All those things are just, you know, top of the list, aren't they?
Absolutely, yes. And certainly computing is one of them. And if you're interested in computing, artificial intelligence and up and coming industries are the new 5G system for mobile phones. And of course, electric cars. And of course, space travel, and that's what we'll be looking at in a moment. So you can be working from anything from satellites to submarines. So there's a huge choice. And remember that you're at school for about 10 years or so, but you could be working for 50 years or more. So make sure you choose something which you really like doing.
Absolutely right.
I'll just tell you a little bit how I happened to get interested in it, because it might help you in a way. One of my friends at school built a crystal set, and this is a radio which doesn't need a battery. And I thought, heck, that's rather interesting. So I then went on to build 1-valve and 2-valve radios, similar to the modern transistor radios, so that I could listen to the pop music coming from Europe on Radio Luxembourg, which was great fun at the time.
I remember that radio station. I used to listen to it late at night when I should have been asleep.
It was great fun, wasn't it? Yeah. But the point I'm making is it's very useful when you're your age at school to build models and try things out, because you get to know what you like doing, and also it helps with your studies. And it stays with you for the rest of your life. So the skills I gained from making little radio sets when I was at school helped me for the rest of my life. I was going to show you this video now, but I'm going to put it on at the end, hopefully, because of technical problems and one thing or another.
So sorry to cut into you, but I don't know if you know this, but we have over 400 people participating.
Wow.
I know, and the chat is already alive. So I'm going to be dipping in with questions as they come in. And just to say, somebody's already asked, can you show us the radio if you still have it? Do you have?
I've got lots of radios I could show you. Yes, lots of radios. Okay, well, I'll try and dig one out a bit later on.
Oh, thank you. And that's from Armin Sharizi. Thank you.
Oh, hi. Well, I'm glad you're interested in electronics, because it does, it's so important in modern life, isn't it? What we're going to be doing now is programming a moon lander. And as you can see, I've said here, programming is very important for engineering nowadays. And it's very widely used for simulating, i.e. making sure that your designs work well and optimizing the designs. And in this case, we're going to be simulating how to program a rocket ship on the moon. So start up a new Scratch project by going to https://scratch.mit.edu if you haven't already done. And then click on Start Creating. And the first thing we're going to do is add a backdrop. So what you have to do is click at the bottom left-hand side of the screen here, which says Backdrops.
And I created a desert for me. That's what I went for.
A desert? Wow.
Sahara.
Right. Well, when you click on Backdrops, it brings up a little sort of menu of different items here. You want to click on the bottom one there, and that's brings up the backdrops. And you want to choose Moon, or click on Space and type Space in the top left-hand corner here, and then double click actually on Moon, and that will add the moon backdrop to your computer program. So we're setting up the initial conditions. If we're in the engineering department, we're setting up the initial conditions for our simulation.
Robert, I have a little question for you.
Yeah.
It's from Atisha Jan.
Yeah.
What qualifications would you need to become an electrical engineer?
What qualifications do you need? Well, ideally, you need to do maths and science at school, preferably physics would be a great help. And then if you want to become a chartered engineer, you want to aim to go to university, at least try and get A levels, because that way you can easily get into the apprenticeship scheme. And one of our most famous scientists or engineers ever, Michael Faraday, who made discoveries which changed the world, actually started as an apprentice. So it's a very good way to start, and you can talk to people in the company in which you're working and say, how did you get involved in this? And they'll help you. They like to help young people.
Oh, that's great. That's great, because a few people are asking, is engineering a hard job?
It varies an awful lot. I was saying earlier, you can work in many different areas. You can work in sales, for instance. So from that point of view, it's not technically hard. You need to know the company's products and travel around. And like installation and commissioning, you can travel the world and get paid for it. So it's like having two salaries.
It's like you were saying, though, if you're interested in something, because you could work for 50 years, then there's a role for you in engineering, isn't there?
That's right. Yes, there's a whole role. You could, because the technical schemes, technical landscape is changing all the time, and we're now looking at, say, electric cars and the 5G new mobile system. There's always something new coming along, and as you gain experience, you become more and more valuable to employers and the rest of society, and you can do things which help people, things like that.
People haven't got on there yet. They're asking for the link.
Oh, right.
Really can type that into the chat, please. That would be awesome. So do look out in your way.
That's for the link for Scratch. Is that the link for Scratch, Vail?
After, yeah.
Well, I'll go up a page. Let's see. Here's the link here. Can you see that all right? HTTPS, then : / then scratch.mit.edu. Okay. And then I say, once you get up, we need to put the backdrop on here. So I better give you a bit of time to do the backdrop.
While they're doing their backdrop, Jamin Jethwa was asking, what qualifications do you have, Robert?
Well, I went to university, so I did electrical engineering electronics degree. And then I went to work for Rakel BCC. That was my first employer. They were making military man-packed radios in those days, the type of radios which don't stay tuned to one channel. So they were called frequency hopping. So the enemy couldn't tune in and listen to what you're going to be doing next. So that's how I got going. And then later on, I went to work for the BBC, which was great fun on outside broadcasts. And I really enjoyed that, and so on and so on.
You know a lot about broadcasting, and there was an earlier question about radio valves. I need to find it. Vivian Verma was just saying, what is the difference between one valve and two valve radio?
Right. Well, the valves are used to making the signal stronger. When the signal arrives at your radio set, it's a very, very weak electromagnetic wave signal, and we need to make it stronger in order to drive your headphones and drive loudspeakers and so on. So a two-valve radio makes the signal stronger, and it's less critical to operate in actual fact. Okay. I don't know if that operates. So I hope you've got your Scratch up going. As I say, the first thing you need to do, click on Create. Once you go to scratch.mit.edu, click on Create, and then click on Backdrops here. Click on the little magnifying glass icon, and then click on Space or type Space there, and you'll get the moon backdrop. So I'll go back to the next page.
This now, Robert, and some people I think are going to do this after, and they're like Woody in Melbourne, for instance, is asking how easy is Scratch to use?
Yes, I think Scratch is very, very easy indeed to use.
I used it. I'm a
Sorry?
thousand years old. It's easy.
It's easy to use, yeah, and it's great fun to play with. There's lots of online programs that you can play around with. Really fascinating programs too. The next operation we need to do on our program now is to add some sprites. Sprites are the bits and pieces we have on the screen here. So the first thing we're going to do is to add the Earth on the horizon here. So click on the sprites icon here down at the bottom, and that will bring up another menu, just like the previous one. I'll just go back a page. So it'll look a bit like this, but it'll have sprites. So type Earth in the top left-hand side there.
Can I ask you a quick question?
Yes.
Toby Cloves is asking, can we code on Unity or Codo instead of Scratch?
Well, I'm not familiar with them, I'm afraid to say. So to be honest, I can't answer that question. But I'm sure you probably can do similar type of things. You can type in many different programming languages. Scratch, though, is very easy to use. That's why I chose it for this demonstration.
It must be easy because Abhidra Joshi says he's done it. He's done.
Well done.
But somebody else was asking, I think it's an anonymous one, can you program a real world robot, i.e. a drone, using Scratch?
Yes, I think there is a system called S4A, which means Scratch for Arduino. And Arduino is a tiny microcomputer which you can use to control things.
Okay.
And I did try it a few years ago, but I haven't tried it recently. And it's probably more complicated than using the on-screen version, but it's probably doable, I would say. So have a look at S4A. Do a Google search on S4A. So once you've got your Earth onto the screen, set the size here to 35%, just the little size box in the screen here, type 35 in there, and then drag the Earth up to the top of the horizon here. So we've got a nice space scene there. Now we're going to want to add Pico. He's going to tell the users how to operate the program. So click on Sprites again, and then when you get to the, I'll go back up to this screen here, type Pico in there, in that corner there. And you should get Pico onto the screen, and then set his size to 35% again, and drag him down to the left-hand corner of the screen. And then for the next sprite, which is the rocket ship, the most important bit, click on Sprites again. And then in this part of the screen, type rocket, and you'll get the rocket ship onto the screen. And then set its size to 35% again, and drag it up into the middle of the screen there. And then we should be ready to go. Keep our fingers crossed. Now then.
David May was asking, how did you get the idea for this?
How do you get the ideas? Well, in the old days when I was at school and university, the computers were very primitive. So we used to program in different languages, Fortran and BASIC, and we used to program Moonlander in this Fortran or BASIC, and it was great fun to play.
Wow.
But things have advanced now. Scratch is much more fun. You get a nice pictures and everything else.
William David's asking, are you going to do coding whilst creating this model?
Well, you'll see coding is done by using drag and drop technique. So I'm going to explain that now, so you'll see what I mean by coding. So it is coding in a way, but it's a very easy way to do it. So it's a very good way to learn. As I say, when you're writing a program for other people, it's very useful or very important to tell the user exactly how to go about it. So we're going to tell the user how to play the game now. So the first thing we do is go over to the left-hand side of your screen here and click on Events, and drag this when green flag clicked into the programming area. Make sure you've got the programming area here, because you'd click on code if you haven't. So drag the green flag into the center of the screen. And now we're going to code on Pico. So if I go up a page, click on Pico there, that's important. And make sure that the green flag is on the Pico screen. You should see Pico in the top right-hand corner there. So to tell the user what to do, we go to the Looks section, click on there, and then drag out Say Hello for 2 seconds and put it in the bottom there. It starts off by saying Say Hello, so we change that to press the space bar to start. So we're telling the user how to start the screen.
Can I squeeze another question in while you're doing that?
Yeah.
Eid Islam was asking, is engineering included in every technological product?
Well, of course it is, doesn't it? We have to do, somebody has to do the design for it. So engineering is included in absolutely everything. And there's so many different areas which you can work in, which is nice, like sales, I say, or you can work even on the financial side if you like that sort of thing, or you can work in design.
Right. So a question from Aditra Krishran, who was saying, is it related to astrophysics? Then I guess the answer would definitely be yes.
It is, yes. Of course, there'll be other specialists working in that area as well, particularly physicists and people who are working in rocket science and so on. And we're very lucky in the UK. We've got Aerobus, which if I can show you the video later on, Abby Hutty is wearing. Sorry, are you going to say something, Fayon?
No, I was just thank you. And Vikram Kohan was just saying, how many different areas are there in engineering? And, you know, I know from doing, you know, different fairs that there are hundreds of different types. But what would you say?
That's right. That's right. There are just hundreds of different types. There's chemical engineering, mechanical engineering, electrical engineering, electronic engineering, programming, and there's space engineering. And so the list goes on.
It stems off from there. Within each of those, you've got loads and loads of other strands, haven't you?
In there, as I was saying, yes, you've got design, you've got research, people who are trying to make absolutely new discoveries. And the employers are quite different. The researchers tend to work for universities or the government or very big companies, something like that. So this is just a little explanation. As you approach the moon, the gravity starts pulling you down. That means your velocity downwards keeps increasing and you approach the moon faster and faster. You have a limited amount of fuel. So if you run out of fuel, the lunar lander is going to crash on the surface. So we've got to prevent that happening.
Why not? Question, I'm so sorry. There's just
carry on.
I love this. There's a question of, is it physical work or more static work? And I think you kind of answered that already with regards to how many different types of engineering there is.
Yes.
But Abhidra Joshi was asking, what does an executive director do in the field of engineering? Would you know?
Well, typically you're sort of planning the new products. It depends. If you're a technical director, you'll be looking very much at the technical side of things. And if you're a sort of executive director, you're probably looking at the financial side of things. You want to make sure you've got good products, which will keep everybody in employment. And probably one of your most important roles is leadership, going around and talking to everybody. As you get more senior, it's more difficult to know what's happening on the ground level, you might say. Yeah. So it's very important to go around and talk to everybody on the shop floor if you're a senior guy and say, what are the problems? You know, could we be doing anything better? Yeah. I think the Japanese are very good at that sort of thing, and the Germans.
It's a great way to be a manager. You know, it's not like you're up here and everybody's down there. You've got to come in the middle and make sure that you are communicating, because that's what makes everything work so well.
That's right.
Woody Melbourne is also asking, what inventions have you made while you're kind of doing this?
Well, you tend to specialize in certain areas. So I was working on synchronization typically. So working on synchronization of the latest digital video and audio systems. We also worked on collision avoidance radar for cars, which will be important if cars become sort of self-driving.
They are.
Things like that, and GPS satellites. So we're looking at synchronization, the new Galileo satellites, which have gone up fairly recently, you know, working on that. So coming up with patents for those, that were the last new ideas I came up with.
Thank you.
With
Brilliant.
other people helping me, obviously, not the only one. Yeah, so as you burn the fuel, the rocket gets lighter, so the pull of gravity is less, but we're not taking account of that in this particular simulation. By firing the rocket's motor, you can slow the rate of descent, but this uses up fuel, so you've got to make sure you don't run out of fuel, otherwise you'll crash. And you want to touch down on the moon surface nice and gently. So we now need to tell the operator how to fire the rocket's motor. So we'll click on Pico still and drag another say hello for 2 seconds, put it in the bottom underneath the press space bar to start. And then instead of hello, type in use the up arrow key to fire the rocket motor and slow your descent. Now, it's a good idea when you're programming to check everything's running okay. So click on the little green flag there and make sure what happens is what you're expecting to happen, because it's very easy to make a mistake.
Cross fingers.
So we're now going to model the fuel usage and the descent. So we need to program the rocket by adding a method to fire the rocket's motors. So that will use fuel in the rocket and slow its rate of descent.
Can I ask more questions when
yes.
you point where they're doing stuff?
Yeah.
Good time? I've got so many questions.
Is that okay? How are we doing for time? Are we all right?
We're doing okay. We've got about 12 minutes.
Right. Okay. So,
and then we'll do a Q&A towards the end.
That's right, yes. And I say everything will be up on the website, hopefully. So if you get stuck, you know, you can do it later and have fun later. So we're going to start programming the rocket now. So click on the rocket at the bottom of your screen here and drag and drop when space key is press block from the event section. So there's the event section, which is light yellow, and drag out when space key is pressed. We may have to change it to up arrow key is pressed. So when you drag it out, it'll probably say when space key is pressed, but click on the little arrow here and that will change to when up arrow is pressed.
It's really self-explanatory, isn't it? It's so
It is. I think it's very, very nice from that point of view. You can concentrate on the main things and you have a bit of fun seeing the pictures too. Now then, we're going to add an if-then statement. So programs are controlled by if statements, which make decisions, and repeat statements and so on, which you'll learn about if you do computing at school. But first of all, we need to create a couple of variables called velocity and fuel in order to track the rate of descent and how much fuel is used. So first of all, drag out an if-then statement from the control block and put it in the bottom there. And then go down to the variable section here and click on make a variable. And make your one variable called fuel. And then make a second variable called velocity. So that will give us two variables, one to check the amount of fuel left and one to check the velocity.
Yeah.
Now we want to make sure we've still got fuel left, so we need to make decisions. So drag a green operator block from out of here with angles on, and it wants to have a greater than sign in the middle. So that's like a right arrow, you can see it here.
Yeah, yeah.
And then go to your variables and drag a fuel variable and put it into this left-hand side, and then put the decision block into the if-then-else statement, and you'll come up with that. So finally, if the fuel is greater than 0, then you can obviously fire the rocket's motors. So we'll change the velocity. So we'll do change velocity. Go to the variables block again and drag out a change velocity by. If necessary, click on the little down arrow to get the velocity here and type 5 into there, change velocity by 5. That's the amount we're going to change to slow the moonlander's descent. And I also want to change the fuel. So drag another change block out and change it to fuel, change fuel by -5. So when the up arrow key is pressed, if the fuel is greater than 0, we can fire the rocket and change the fuel level. Right.
Do a countdown before you launch.
Well, yes, though, I'll show you what that says. I'll show you how that, once you press the space bar, you'll see you'll get a little message saying, let's go. Right, so we're going to model the ascent to the surface of the moon. So we've got to first add an event flag. So we're still in the rockets, coding to the rocket now. So drag a when green flag is pressed block from the left-hand side of your screen into the center of the screen. And we're going to make 2 more variables now, one called YPOS for the position up and down on the screen, and one called XPOS to record the left and right motion, although that won't change in this case. So make 2 variables, one called YPOS and one called XPOS. And then from the left-hand side of the screen, drag it out and put it underneath the green flag, drag out a set YPOS to 140. So you have to click on the little down arrow to use your new YPOS variable. At the same time, go to the left-hand screen, drag an XPOS, set XPOS to 0. So you may need to click on the bottom there, make sure you've got XPOS there and YPOS there. Make sure you've got 140 here and 0 there. And finally, we want to make the rocket move. So we go to the left-hand side of the screen and get a motion blue block, drag it out and put go to XY. And in the XY, use your 2 variables, XPOS and YPOS. So that's the coding. You should end up with that, a separate little block like that.
Wowzers.
So later we'll need to accelerate the rocket down towards the surface of the moon to mimic gravity, and we'll use a repeat until loop, which operates in 1 second steps in a moment.
Okay.
And then later we'll need to repeat that.
Robert, we've got 7 minutes until we finish, and I've got a heap of questions for you.
Well, I'll keep going fairly fast, but you can ask the questions at the same time, of course. So we've got to model the fuel usage now. So this is when space key is pressed. So we're still coding for the rocket. So drag out a when space key is pressed from the event side. And we're going to initially set the velocity. So from the variable side, get a set velocity to -10. Remember, the velocity is going to be changing as time goes by, but you'll see how that's done in a moment. And initially set the fuel to 140. So from the left-hand side here, variables, drag a set fuel to 140. And then as you were saying, we've got the countdown here. So once the space car is being pressed and these 2, the velocity and the fuel at the starting initial conditions are being set, we say, let's go. Right, so let's get cracking. So do an initial test now. Say always do a test as you're doing your programs, make sure everything works correctly. So click on the green flag at the top of the screen here and make sure everything happens that you expect to happen. Pico should say, give his instructions, and everything should move to the starting position. So now
while they're doing their test, can I ask you a few questions?
Yes.
So Nidarko wants to know, what qualifications do you need for civil engineering?
Civil engineering, I'm not, to be honest, being an electrical engineer, I'm not quite sure. But if you have an engineering degree, particularly a mechanical engineering degree, I would think, but I think there are civil engineering degrees, I'm not sure. But physics would be a very good one to do.
Yeah. So
physics degree.
The question from Sean Sarishny, I think, are there multiple degrees for engineering and which are they? That's probably not your expertise to answer that, but there are so many organizations out there. Where would you start? Where would you begin looking?
Well, I should certainly look at the university websites. If you're thinking of if you'd like to go to a particular type of university, look on their websites. They're very good. And they have lots of information on what sort of degrees they do and choose one that you like. If you're not quite sure which area you want to do, I should choose a general degree like physics, which is a very good degree. But if you're more specific, if you definitely want to do electrical engineering, electronics, then obviously we go for that. And similarly for civil engineering or chemical engineering or whatever. So we're going to add this repeat loop. We've just done the top bit here. So we said, let's go for 2 seconds. So we're going to add a repeat until block. So go to the left-hand side of your screen and bring in a repeat until block. And it's going to repeat until ypos is less than -105. So you want to get a green decision block, which has a less than sign in it, and drag one of your ypos variables, stick it into the left-hand side, and type -105 into the right-hand side. And this is a repeating loop. So to mimic the velocity downwards, we're going to increase the velocity downwards by -5 every second. And then we're going to move the rocket ship to its new position. So drag from the variables block, drag a change, and then click on ypos and insert your velocity variable into there. And then from the left-hand side, drag in a change velocity this time by -5. And then from the top left-hand side, the movements block, go to, and then add in xpos, ypos. And then from the control section, and this is sometimes a bit tricky to find, drag in a wait 1 seconds block. I don't know how we're doing for time, but I'll have to crack on, I think.
We've got a couple of minutes, and I've got about 1,500 questions. I've got
Oh dear, I'm sorry. Anyway, send in your questions, we'll answer them all for you.
Okay.
So this is the modelling the rocket's landing. This is the very end of it here. So it's the very end here. You've just done that bit there. So after the repeat loop, add an if-then-else loop. So from the control section, add an if-then-else loop. We need another decision variable here. So from the operators block, drag in a green greater than, and then put velocity in the left-hand side. If the is greater than -50, then we use a looks block to say, well done, you landed safely. On the other hand, if your velocity was greater than that downward, you can say, wow, you crashed. Or you silly idiot, you've just blown up $1 billion or pound rocket.
Whoops.
And that's the final slide apart from the videos. So test your green flag to see if it works correctly so far. And think about how much fuel you need and how you could make it more difficult for other people to play the game, and what are the variables involved, what else you could add.
Wow. Right then. So yeah, the students can really go crazy on this, but I have some questions to ask you. So I'm going to send them to you. If you could give me very brief answers, we'll do our best to get through as many as we can before we move on to our next speaker. So Fayaz Shahil wanted to know, how do you get the simulator accurate?
How do you get the simulator accurate? Yes, well, that's by taking very careful measurements and calibrating your instruments before you take the measurements, so you know what the variables are. We could, measure the mass of the object. In this case, the moon lander. I think I looked on the website. They're about 2,700 kilograms.
Wow.
And you have about 2,700 kilograms of fuel. So you'd know those as actual figures, you might say, which you could use.
Okay, another question. Arman Shirazi was just asking about your friend from earlier who made the radio. Was it a school project, or was it just something he or she was interested in with regards to engineering?
It was just he or she was interested in them. He used to love making things like model aeroplanes they used to make out of balsa wood. And he had to make up this little radio, which didn't need a battery, and you could still make them nowadays. They're great fun. You need a long aerial, a long wire, in other words, to pick up the signal.
I hope this question for Ali Mirza was asking about how you make the sprites smaller.
Yes.
Double clicking wasn't helping for them.
No, that's right. So to make that slight sprawl, you need to click on the sprite. So it's the rocket sprite. You click on that part of the screen here. And then in the center, just below the picture, it says size. And to the right, there's a little entry box there. So you type in the percentage you want to make it smaller. I've put 35% in my screen. That's how you do it.
Okay, so with regards to people that might be using Python or other things, you're not using that particular one, but for the information that you've done today, everything you've done today, the schools have received this, the codes.
Great.
Link, and so you should be able to go back over that yourself and ask teachers or parents, friends to help you. And it's not even about getting it right, it's about experimenting, isn't it?
It is. It's all great fun, and I'm very glad to have the opportunity to tell everybody about it, and also to watch the ice cream video. Look forward to watching the next one. And thank you, Freya.
Well, before you go, I'm going to see. Can I just squeeze in a couple more questions before you?
Yes, of course you can. Yeah.
Wonderful. There's so many that have come through. So, Bilawal Chowdhury. Please send your question again so I can ask it, please, because when I say there are hundreds coming through, so yours has slipped through the net, but hopefully I'll get to it in a minute. Okay. I think it's Fayaz Sakil is asking, when they do simulations for real life, like, for instance, when they do NASA and they use their rocket, how do they know it's accurate?
That's right. Only by taking measurements, maybe doing small scale measurements on models. Like we're actually doing a computer model here, but you could actually build a model and take measurements. In the communications area, we would simulate a communication channel and then add noise to the channel, things like that. But you could also measure it electronically.
Okay. Bilawal, I found your question. They were just asking who invented electronics?
Well, of course, it goes back to the ancient Greeks, I think. There's a chap called, I forgot what his name was, Magnet or something, a name rather like that. And he found that the nails underneath his sandals used to stick to a rock.
Oh.
And that information, I think, went to China, and they invented then a magnetic compass.
Wow.
And the information then came back to us, and then we developed it in Europe, in Italy, France, the Netherlands, and in the UK. We all took it further.
Fantastic. And somebody else was asking, you can see the actual code, bracket, not drag and drop, by clicking on a button somewhere. Oh, they're answering somebody's question. Thank you so much for that. Somebody else is asking, is it possible to change the hitbox of a sprite? You can set the hitbox to Godot and many other softwares, but you don't know if it's possible in Scratch. Is that true?
I don't know. I'm sorry, I can't answer that one. I don't know.
I'll get to a couple more questions because you didn't invent Scratch yourself. It's just something that you've chosen to use because it's nice and easy. And here we go. Let's see. Right, okay. Right. Okay. Right, yeah. Apologies for asking questions whilst the actual experiment is happening, but there are just so many. So thank you for your feedback on that. I don't know who sent it, but thank you. But there's so many questions. I don't think I'm going to get to all of them. So can I ask you, if anybody has any other questions about this, is there any way they can ask them to you?
Yes, I think if you send them by email, I don't know.
Are you happy to?
Yes, I mean, send them to my email, or maybe use a different email address. I don't know.
You know what we could do? If they could send them through to us.
Yes.
Enjoy Science, Enjoy Sutton, then we will get those to you, because I feel you're probably going to get about 300 questions.
Oh, good. I'm glad to hear that.
with those. So I will end with one more question. One more. It's from Sebastian Sorisco. He says, what is your favourite part of engineering?
Well, it's coming up with new ideas is the favourite part, and seeing something new working correctly. That's great fun. You get a tremendous sense of achievement when you see something working well.
Brilliant. Robert, I feel we could have more than an hour's session, 2 hours session with you. It's been really fascinating hearing everything that you do, and thank you for taking the students through Scratch. And of course, if they want to go on and try it out as many times as they can, then the link is there for you. So please do that. So thank you, Robert.
Right. Thank you for all your help. Bye.
Thank you. Bye-bye. Brilliant stuff. Honestly, so fascinating. So waiting in the wings, coming out of the green room, it's now time to test gravity. This is really fantastic. Using technology to augment the human body, this is where we're going with this. This company, Gravity, has been sort of making some really pioneering breakthroughs, and we're going to hear about those now. Anthony, are you there?
Hi, Fayon. Can you hear me?
Yeah, loud and clear, my friend. How are you doing?
Yeah, really good, thanks. It's really exciting to be part of this science festival today. So thanks for the organisers for letting us join in.
Absolutely right. It really is. And like I was just saying to Robert, we could do it longer because there's just so much interest in everything we're doing. So let's crack on straight through this. So thank you for joining us. How are you going to tell us about gravity?
Well, what I'm going to do, I'm going to talk to you about a journey. It's a journey that started with a crazy idea to challenge the way that humans fly. So rather than putting a human inside a helicopter or an aeroplane, could you augment the human body and mind with just the right technology to allow them to fly? And what was the reason for this? Well, it started out just for a bit of fun, just to ask, what if? Now, I'm going to share my screen. Quite a lot of what I'm doing is showing videos today, so hopefully you'll get to see them. It might be a little bit laggy, I apologise for that, but let's give it a try.
And just to say, Anthony, with your presentation, we are going to leave questions until the end. So we need to leave time for that. We've got until 12:05. But do you think we can get to questions by about 5 to 12?
No. Yeah, no problem at all. What I'll do, I'll show you some videos for about 10 minutes and I'll talk through them. And I know it will prompt lots of questions. So please ask them. I'm sure we've got answers to all of your questions. I'm actually looking forward to hearing them. So let me tell you the story and it will prompt questions, I'm sure. So let's just share screen now. Okay, you seeing that?
Yes.
Excellent. So this chap here is Denton Conte, and now clearly he's a remarkable athlete, but what he's showing here is how humans are equipped with the right balance computer to be able to relearn how to remain stable whilst using different parts of our muscle and skeleton system. Now, whilst living in London, this incredible skill inspired someone who Denton was training. This is Richard Browning. He's a former Royal Marine reservist. He's a successful London city trader and someone who had a family background in aviation. And he was the man who started this journey into human flight. He had the idea that if you could balance like this on bars or rings, then perhaps you could balance like this on columns of air from a jet engine. Now, not only did that seem ridiculous to his friends and family, it seemed pretty ridiculous to him too. But here's a man who, he's an innovator. He thrives on learning by experience and, if necessary, learning by failure. And so he just had to experience the failure for himself. So he bought a jet engine. So this is a micro gas turbine engine with about 20 kilos of thrust and a homemade mount to stick it onto his arm, a mop bucket full of jet fuel, and some hearing protection. And you can see it blowing the grass on the other side of the road there.
Wow.
Now, straight away he realised that so many of the myths and concerns about this just evaporated. The engine didn't rip his arms off. The rotation didn't pull the turbine off in one direction or another. The noise was manageable and the heat was manageable. So he did the only next logical step, and he bought another one. So you can see here how his power jumps are really keeping him levitating in the air just a little bit longer than a normal jump. And this is about 40 kilos of thrust pushing up his arms. And it was still perfectly manageable. So where would you go next? He bought two more and put them on. So there's a real sense of balancing on columns of air from the jet exhaust coming out of Richard's arms here. Long, slow jumps, but he's now staying up in the air. But there wasn't enough lift to overcome his weight. So where do you go next? That's right, 3 on each arm. This is nearly 70 kilos of thrust up each arm. Very heavy, pretty dangerous, but a valuable part of the learning journey. This was, after all, a series of controlled experiments. This wasn't going to work, but there is enough thrust now. So the next step seemed to make sense, moving some of those engines onto his legs. Now, humans use their legs to balance, to move. Our legs are stronger, so surely this would be easy. So we started out with lower thrust, 1 engine on each arm, 1 on each leg. Let's have a look at this. Doesn't quite work as we all might have expected. And actually, having that safety tether, which prevented him from falling, actually provided a 5th force on his body. So 1, 2, 3, 4 on his arms and leg, and then a 5th force that was pulling on his back, which was actually unpredictable, uncontrollable, and it actually hindered his progress. So maybe we'll get rid of the tether and keep all the engines. So now we've got 2 engines on each arm, 1 on each leg. So we know there's enough thrust now. Starting to get there. But actually having leg jets didn't work particularly well. Now, if you imagine holding a dog over a paddling pool or over a swimming pool, if anyone's done that, their legs just start to paddle just by instinct. And it seems that when humans' feet leave the floor, we do the same sort of thing. We try to run to regain traction. Now, when you've got 20 kilos of thrust blasting out of each of those running legs, what happens is as you start to move, it will push your leg and then your whole body moves and you start to go in ways you don't intend. And so having to relearn, again, like we talked about at the start, having to relearn how the human body can maintain balance. There was all sorts of other learning points about leg jets as well. So recirculating the exhaust from the arm jet went down into the leg jet. Jet engines like cold air, we can talk about that in a bit, and so putting hot air into them makes them lose thrust. Or maybe even just his feet getting too hot standing on the ground because the exhaust was heating up the concrete. But all the ingredients were there, and so by making technical adjustments, relearning a different method of balance to counter your natural reactions, this happened.
Wow.
Now, that was the very first 6-second human flight in a suit made of jet engines. Richard Browning had done it. Well, almost. At the very least, he proved that the concept was technically possible. The next step was to learn to fly the thing. And he did that in secret. During this period, there was lots of development to the jet suits. The leg engines moved from the legs onto his back. Those 2 engines were combined into one larger, more powerful single engine, and Richard created the company Gravity Industries to develop and to market the concept. And in the space of about 18 months, he reached this end result.
Wow. Amazing. My goodness, look at that. That is so cool. Oh my goodness. What's the cost? I want to know the cost. I want one.
Oh, we can talk about all of that in a bit.
Was that Chris Evans just then from radio?
He's met all sorts of famous people as a result of doing this.
Wow. Awesome.
So here it is then, the world's first jet suit made up of 5 microgas turbine engines. There's a back jet, twin arm mounts. Each jet suit is tailored to fit each pilot. The whole thing, well, this is remarkable now, is completely 3D printed. It's got 2 fuel bladders, a helmet with a heads-up display, and I am sure that you've got lots of questions. So, although it never gets boring watching it in action, I think let's hear some of the questions you've got, Fayan, and then any that we've got from the floor as well.
Okay, well, they have to come just from the floor because there's so many.
Okay, good.
Will be answered as we go along. So, Biswal Chowdhury wants to know, how long did he work for Gravity, first of all?
How long did I work for Gravity? Is that it?
Yeah.
Okay, well, the Gravity team is actually made up of a small group of people from all over the world that a lot of them have other jobs as well. So there's a small core team that do the research and the development, and then there's a number of us that are supporting from all over the world. So I've been supporting Gravity in a number of different ways for about 2 years now.
Fantastic. And there's a question come in as, have you, and I know the answer to this, have you ever flown?
I have flown. I'm very pleased to say I have flown. Now, one of the ways we train pilots to fly this is we've gone back to the tether. So we've got in fact, I'll show you the training rig. It's good to see while I talk through it. Right, here we go. Excuse me. Can you see that?
Yeah, I can see it.
Okay, I'm hoping everyone else can then as well. So imagine a giant metal frame the size of a house, and with a zip wire across it. And what we do is we start off on low power and let people get used to the incredible feeling of having jet engines strapped to your body. Start to build the power up a little bit more each time. And oh no, I've just been told you can't see it. Terribly sorry. Hang on. Oh, sorry. Okay, not to worry. I've described it anyway. So a big metal frame with a tether hanging from it, and you then use that to practice safely learning to fly, because if you fall, then it'll catch you. And then increase the power more and more, and eventually we remove the tether once people are ready, and then they can fly anywhere they want.
Fantastic. Levan wants to know, is it true that because there is no air resistance, the hammer and feather will fall at the same speed?
Okay, well, that's referring to inside a vacuum. Now, we don't fly this inside a vacuum because that would mean we'd be up in space, although it is actually quite similar to one of the ones that the astronauts use to do some of their spacewalk, so using forces to move themselves around in 3D space. But the pilots who fly the gravity jet suits, there absolutely is air resistance against us. Now, humans are not aerodynamic. We don't have wings, we don't have aerofoils. The only way we can fly is like this, is using lots and lots of thrust. So we have to overcome gravity, first of all, and then we have to overcome, exactly as has been said there, the air resistance. And that's what these engines allow us to do.
Okay, there's a question. Have you had any projects other than experimenting with how people fly?
Have I had a project? Gosh, I've had hundreds of projects, and I think anybody who's working in engineering or science or anything innovative and exciting just is naturally drawn towards projects and trying things out. And I would encourage everyone to do that. It almost doesn't matter at this stage what it is you're experimenting with or have got a project in, but just do it. And the more you do, the more you'll start to realize where your interests lie and what you're good at. So, yes, I have, but I couldn't even list them all now.
For another show. Vikram Chauhan is asking, what is the gas that is thrusting the man in the video?
Okay, well, the engines are jet engines, so exactly the same sort of jet engine that you'd find on the side of a jumbo jet, an aircraft that you go on holiday with. They're just a lot smaller. So they use fuel. So there's two fuel bladders on our back, and that kind of fuel is called Jet A1. So it's jet fuel, but it's just kerosene. You can actually run this on diesel. So the same fuel that goes in your family car, you could run these jets on. It's burnt inside the combustion chamber. This explodes and then fires hot exhaust out of the other end. Now, those of you who've done Newton's laws at school, which I'm sure is all of you, will understand that if you're pushing something out of one end, the thing you're pushing it out of moves in the opposite direction. And that's what's happening here. So by forcing the exhaust out of the end of the nozzles of the jet engine, the engines, which are strapped to us, makes us fly in the opposite direction.
Gotta say,
now, we've got... Sorry, go on.
Thanks.
Sorry, I didn't hear that one, Faye. I'm sorry.
Don't try this at home.
Well, if any of you have ever done a bottle rocket with water, then you compress the air inside and then it pushes out the water. And the rocket goes in the opposite direction. That's essentially all we're doing. These are, we're using the chemical reaction of combustion inside the rockets rather than compressed air and water like you do in your bottle rocket. But in theory, you've already tried this at home. This is the same sort of principle.
Okay, that's fine then. Haris Hassan is asking, would he also have to account for the weight of the jets and the fuel? Is that why there was not enough thrust? That's
exactly right. You're really thinking carefully about this now. It's not just the weight of the pilot that we've got to lift off the ground. It's the weight of the pilot with the engines, with the fuel, and then the airframe that holds it all together. Now, if you add more fuel, you'll be able to fly for longer, but then you're heavier. So then you're going to need bigger engines. Now, they're heavier as well, which means you then need more fuel. And there's this balance that everyone who's building any kind of aircraft at all, whether it uses wings, whether it's a helicopter, whether it's this just using thrust, anyone has to balance the weight of the aircraft, the weight of the payload or the pilot, the amount of fuel it can carry, and all of those things are a very careful balance. So yes, absolutely, we have to consider the weight of all of those things, and including the weight of the pilot. I had to lose a bit of weight before I could fly. I was too heavy.
Okay, Natalie and Noxie was asking about how much does the jet engine cost?
So the jet suit, we call it, so it's a suit made up of a number of different jet engines. Now, they're not really, a couple of them have been sold, and there's a number of different applications where they could be used in industry. They're about the price of a house, shall we say.
Wow, okay, a house in London?
Question, okay. So about £350,000, I think it is.
Okay, all right. My husband's going to come home and find a for sale sign outside my house.
Exactly. What would you rather have? What would you rather have?
A suit.
It's not so much about selling them to people because, if you imagine there's a lot of training involved. we're not really making them to sell them to people, because we don't really see people flying around getting their shopping or flying to school in them or anything like that anytime soon. But what's being worked on is a race series. So imagine a number of jet suit pilots racing each other around obstacles, over water, over land, with huge crowds cheering, and you can follow the celebrity pilots. Does that sound pretty interesting?
Yeah.
Do you want to see a clip of that?
Yeah, you can.
Let's see if I can find that.
While finding that, can you answer this question from Toby Eves? How much power does it take for each second of airtime with the engines?
Okay, so talking about power here is probably a bit misleading, but let's talk about how much fuel we burn, and it's I think it's each engine, or rather the whole suit, is burning about 4 litres every minute. So 4 litres of fuel every minute. And that creates enough power to lift the pilot off the floor. But what we say is it's about the equivalent of 1,000 horsepower. So that's the sort of the number that you can throw around. Right, I found the presentation. I will do a share screen and you can have a look what jet suit racing would look like. Are you seeing that?
I can see there's yeah, I can see the screen. I can't see anybody racing yet. Oh, hang on. Here we go. Yeah, I can see it. Cool. Where is this being filmed?
This was at a lake in Reading. There you go, someone's crashed.
What fun.
So things have moved on quite a bit since this video, and we've now got pilots that are trained and have been increasing their skill level, getting faster, doing more dynamic maneuvers, and getting sponsors. And we were due to have our first race out in Bermuda, but it was going to be in March, and obviously that had to stop. But if you, if everyone who's watching starts looking at Take on Gravity on Instagram and YouTube, then you'll be able to see what's happening and all the developments leading up to the first big official race series.
Oh gosh, it's so exciting. It really is. Did we cover, just for Nidarko, did we cover how heavy the suit was?
I didn't get asked that question, but I've got the answer for you. So with the fuel in it, it probably weighs about 30 to 35 kilos. So about the same as a couple of heavy suitcases. But once it's on your back, it's actually, it's okay. Now, if you think about this, as soon as the engines start firing up, they actually take off some of their own weight. So it feels like you're not really wearing anything. And then when you throttle up even more, all of a sudden you weigh nothing as well. So it's only heavy if you're just standing around wearing it for a long time. But actually it's quite comfortable when it's on.
Fantastic. And Prat Joshri is asking, is there any programming involved in this?
We are using the most sophisticated computer imaginable, and every single one of you has got it already. That's what makes this work so well, is that we are using the human brain to control the vectors of thrust. So if you tried to program a robot to ride a bicycle, it would be really difficult to do it. You think about the number of different things that are working together, balance and visual cues, all of this. Yet a 5-year-old can learn it in a weekend. So not the jet suit, I mean riding a bike. That was so using what we know well, which is our arms and our legs and our bodies and our information from our mind, you can just spend a few sessions learning to fly, and you start to feel what thrust up your arms feels like, and then you control how high you are by moving your arms. So if your arms are up, you're not flying. As soon as you push that thrust down, you then take off, and you lift your arms up, you go down. Once you've worked out that balance, you can do it. Now, we had a gymnast who had a go on this, and he got into a stable hover, which is a sort of milestone in training that you can hold yourself perfectly still in the air. And it took him just 4 minutes to learn to get into a stable hover.
Cool. This is so exciting.
But some people really, have that sort of natural ability with balance and core strength and sort of, understanding where their bodies and arms are. But yes, we use a computer. It's all up here.
All up here, the most powerful computer that you'll ever need. And Vidang Pandit is asking, what is the jet engines, or what are they usually used for?
Great question. They're usually used in a number of different things, but predominantly in radio-controlled aircraft. So some, really serious modelers will use jet engines in small-scale models. They're used in also some military applications as well. So these sorts of engines already exist, but what we've done is optimize them for this particular application.
Okay, fantastic stuff. So we have covered, and we've got more time. Good, we've got a good 7 minutes or so.
Plenty more I could tell you, or plenty more I could show you. Here's something. Say again, sorry.
Do show us something else while I call up some more questions.
Well, this is something that people don't normally get to see. I sent a message to Richard Browning about half an hour before the start of this and said, because he's back in the lab now, the research and development lab, and I said, could you have a sweep around, have a look with your camera, so I could show basically an exclusive preview of what it looks like inside the lab. So this doesn't normally get seen, but I will flash it up now. I'm hoping you can see it. Excuse me. Okay, am I sharing screen now?
Not quite, not yet, but we're waiting. We're happy to wait for a second. Can you answer a question while you're looking for that?
Yeah, I can, but I'll talk through a bit though. So you see a number of different suits there, the sort of development of it. You can see it's sort of fully 3D printed there, all the different helmets he's used. There's Iron Man's helmet, obviously. He's flown wearing the full Iron Man armor. There's some of the old suits as well, some of the early development stuff. The original arm mounts up there. I think we get to see the 3D printer shortly. There's one of the 3D printers. There's all the kind of tools and materials that are there. There's a jet suit being worked on by the looks of it on the bench. Various experimental 3D printed parts. And there all the kind of lanyards from all the events he's done. Hundreds of events all over the world. There you go.
Wowzers. Well, I'm hoping everybody got to see that because my screen froze. So we'll soon get to hear.
Well, I'll put it on again while I answer your questions then.
Thank you. So how do the micro engines work? If we haven't covered that one, I don't think we did.
Well, they work in the same way as normal jet engines. So they suck cold air in. That goes into a compression chamber where it is compressed, and the fuel is injected into that compression chamber over a glow plug. It then creates an explosion. It's as simple as that. There's an explosion inside a combustion chamber. That explosion turns a turbine. At the other end of the turbine, there's a fan which sucks more air in. So every time it explodes, it sucks more air in, and it gets into something called self-sustainment, where it will keep itself running as long as there's fuel being pumped into it.
Wow. Okay. And a question here: how many G-forces? Sorry, I've just slipped down from another question. Right, let me go. Here we go. Sebastian Sorisco is asking, how many G-forces is the man pulling whilst flying?
Right. Now, for those of you who don't know, G-force is that sensation you feel when you drive a car over a bump, and you can feel that sort of that sensation. And it comes from your body experiencing forces upon it that are greater than you would normally experience on Earth. Now, we've got some people who are working at universities to kind of measure those sorts of G-forces, attaching different pieces of equipment onto the pilot to measure that. And I've not seen what the readings that come out of that are. But I know that some of the really rapid dynamic stops that Richard can do and some of the race pilots can do, they can accelerate very quickly and they can decelerate very quickly. And I suspect there's about 4 or 5 G being exerted on their body for a very short space of time.
Thank you. Combined question. How long did it take to make the suit in order for the person to fly? And have you ever been in that suit?
Okay, well, I mentioned before that the suits are 3D printed. So the back parts, some of the arm mounts are 3D printed in polymer, plastic, and then there's other parts that are 3D printed in aluminium. There's some fuel lines and connectors and a few batteries. But because it's all 3D printed, you could probably make one in a day. You could, depending on the type of 3D printer, maybe a few days. If the engines were already there, then it doesn't take long to actually build it. And the great thing is, because all of those parts are interchangeable and 3D printed, you can experiment with different arm mounts, with a different back set, that sort of thing. And then the final part of the question was, and have I ever been in one of those 3D printed ones? And the answer is yes, I have.
Right, absolutely. Fantastic stuff. We've got a few more minutes. Do you have another minute's worth of video to show us or anything like that?
Let's have a look. Yeah, we've got some. What should we show you?
I have other questions. Can I just quickly ask you this one before you show your video? Padma Apana is asking, is it possible to develop this kind of engine with fire engines or hot air, cold air circulation? By this I mean using the circulation to make a small tornado.
There's all sorts of things in that. You wouldn't use these engines to do anything other than, well, no, that's not true. Do you know what? Yes, why not? Experiment with it. Give it a try. That's what this was all about. No one really knew whether this was going to work at the start of this, so I'm not going to say no to anything like that. Yes, get one and try it.
Cool. Somebody was asking, didn't Gravity with Colin Firth a few weeks?
Yeah, so Colin Firth is a YouTuber. He's actually learnt to fly the jet suit as well. Quite a bit of things together with Colin Firth. He's a great guy. I've met him a few times, and I think those of you who are following either Colin or Gravity on Instagram and YouTube will certainly have seen that collaboration. Yes.
Cool. Did you find the video?
Let's see, what have we got? Let's have a look at this one. Is this the one I showed you before?
This is the one we saw before.
Sorry, right, let's go to a different one.
While you're finding the next video.
Oh, well, here we go, show you some pictures. So, Guinness World Records, he's flown up at above 85 miles an hour. Now, if you think about just how fast that is, that's flying over water, used a wingsuit on his legs, a couple of wings you can see on the bottom there on his ankles, but getting up to 85 miles an hour is absolutely staggering speed. Let's have a look. We've got, seen that one? Seen that one?
Yeah.
I'll talk about this. This is something you can access on our website. So gravity.co, it's not .com or .co.uk, it's just .co. And if you click on the STEM button, you'll find a series of PDF downloads that talk about Newton's laws, muscles and skeletons, how your ear works, because obviously this makes an awful lot of noise. There's all sorts of, so much science going on in this. And we've got a worksheet, well, not a worksheet, a sort of information sheet about all of these different aspects. So if you have a look at gravity.co and click on the STEM link, but also have a look at Instagram, have a look at YouTube. There's, as you said, Fayon, this is so cool. That never goes away. You know, it really is cool. And there's so many amazing things to look at if you go onto that website.
It's amazing. We have got about a minute or so I'm going to combine a few questions. Will this product be part of aerospace travel in the future? And do you do anything except from creating these awesome jetpack suits?
Will it be part of aerospace travel in the future? It probably will be for certain people, whether that's sort of in the military or in search and rescue or something like that, there may well be people using this, but I don't think particularly that we'll be using them for traveling around. But if you think about 100 years ago, someone probably said that about noisy, dirty cars. And then, so who knows where it's going to go in the future. And doing this was a job that simply didn't exist just a few years ago. So the people watching this now who are yet to make a decision about what jobs they're going to do you know what? Yes, maybe you will be the people that will set up the infrastructure and the refueling systems and all that sort of stuff so that everyone will be flying to school and flying to work in the future. And the question, does gravity do anything else? In terms of, well, first of all, you can buy your t-shirts and caps and various things like that, so you can do all that through the website. But what we do is public events, so air shows, and demonstrate it to the public. And every time we do that, we usually have some sort of STEM capability with us as well. But the main focus is the race series now.
Well, there's quite a few people asking if they can fly one. I'm like, yeah, get behind me. So yeah, there's a big.
Well, I'm glad you asked that. I'm glad you asked that, because that is something else that is on offer. So experience days. So yes, the answer is yes. If wow. You are, if you meet the criteria, which I suspect that children won't, but maybe when they grow up, or you can get your parents to have a go, then yes, you can do that through the website as well. You can make an inquiry and you can book your own experience flying the jet suit on that training truss on a tether and feel what it feels like to have jet engines strapped to your body.
It's like 18 or over, 21 or over?
I think it's 18 or over. Yeah, but there's a number. It's worth, if you're genuinely interested, then make an inquiry and the team will talk to you about it. But it's not really a children's thing. You need to. It's not for children.
Okay, all right then. Not long, guys, not long. So just to finish on one other question, it was an anonymous question, and they were asking, when you got to fly, were you nervous? Were you excited? How did you feel?
I had spent a lot of time watching other people learn to fly. And so I wasn't nervous, I was excited, but I was trying very hard to concentrate and follow the instructions I was being given and do exactly what I was told. And I found that by listening carefully and by understanding what it was I was trying to achieve, I just got to enjoy it. I just got to relax and enjoy it. And interestingly, when you're flying it, even with all of the noise, and it is horrifically noisy, you've got earplugs in, you've got your helmet on, it's just nice and relaxing. There's nothing quite as relaxing and as enjoyable as flying.
Sounds absolutely awesome. We have ran out of time for you, but if anybody has any more questions, I mean, there's a lot of questions, and I'm so sorry I couldn't get to everybody's questions, but if they want to send their questions on to you, is that okay, or should they do that through us at Enjoy Sutton?
No, that's fine. What I'd suggest, though, is to do it through the number of different social media things we've got already. So if you look up Take On Gravity on Instagram, Facebook, YouTube, and TikTok as well, and Twitter, Take On Gravity, then there's the opportunity to start that conversation. And then if you want to follow me on Instagram as well and see some of my training videos and some of the other projects that I've got up to, then I'm at Quinternational. So Quinternational.
Yeah, I'm all over that already. I'm following you, buddy. It's been fantastic speaking to you, Anthony. Thank you so much for your time.
You're very welcome, Fam. It's great, as I said at the start, to be part of the virtual Sutton Science Festival. So thanks for listening, everyone. Don't forget to follow us on Instagram and YouTube.
Wonderful. Thank you so much. Again, another person that we could have spoken to for hours on end, but do go to his social media pages and just follow and see what is going on. So thank you so much, Anthony. Right then, we are getting towards the end, but we've got one more guest for you. Now, our guest has had to get up very, very early to be with us. In fact, it could probably still be night where it is. The dawn is cracking. Our guest is actually a professional drone pilot, an educator, and the co-founder of an awesome brand called the Drone Academy, GADA. They're based over in America, and you guys are in for such a treat. You're going to be led through some interactive presentations, drone technology, how drones are being used in various things, as well as the fight for COVID-19. I've said enough. Eno, hi.
Yes, I'm very well. How are you today?
I'm really well. So you're coming to us from America. You are in Baltimore, aren't you?
That's correct. Yes, Baltimore.
What time is it there?
It is 7:15 in the morning here, so not too early, but it's still early. So
it's not a crap. It's pretty early. Thank you so much for early to join us.
Awesome. Thank you for having me.
So here we go. We've got the numbers just keep building. I don't know, it could be about 100 people on this thing now. We are going to have questions for you. So please go ahead and I'll get those questions in towards the end.
Awesome. Thank you again for having me. As Fayon mentioned, my name is Eno Umo. Most of our students call me Coach E for short. But as mentioned, I am the co-founder of Global Air Drone Academy and an entity called Global Air Media. And essentially, we use drones for various type of projects all around the world. I particularly love coming to London, love coming to the UK to perform some of our workshops. So what we're going to do today is actually go through what we do as a company, show you some of the uses of drone technology, how you can actually become a part of the industry, and then of course talk about how they are being used around the world today. So let me bring up my screen and we can get right into it.
Okay, I'm just already witnessing quite a few questions and you haven't even said anything.
All right. Awesome. Can everyone see? Can you see?
Yeah, can see.
Okay. All right, great. All right, so thank you again. This is, I believe, yes, our second time with the Sutton Science Festival. Last year, if you were able to see us on Sutton High Street or at Sutton Grammar School, we were able to bring out what we call the Drone Zone. So definitely enjoy the invite here, and I'm happy to be with you all. Once again, we do have some social media pages, so you can feel free to look us up at GA Drone Academy. I've also listed my personal handle here, where you can see all my cool travels, and then we are also on Instagram as well for the Drone Academy. So definitely feel free to check us out there. So I wanted to actually show you a video before we get into the full presentation, because it's not just about drones. I am what I consider a creative artist. I love just shooting videos around all the cool places that I'm able to visit in the world. And I actually wanted to show you a video of something that I shot probably a little bit over a year ago, but this is actually some clips of London, and I'm sure you all have seen and been to many of these places, but it was really particularly cool for me because I was able to show all of my colleagues and my friends back here in the States about how cool London is. So I just wanted to show you that video. All right, so just a look at.
How cool it was to see London. Because of lockdown, I live in London. I've been in central London for so long. So thank
Yeah,
you. That's awesome.
no problems. My pleasure. And yeah, that was around November or December of 2018, actually. So yeah, just enjoy putting videos together, and definitely, yeah, well, London is one of my favorite cities for sure. So. Um, so a little bit more about us. As you've heard, we are based in Baltimore, in the US of A. We've conducted workshops now in 9 different countries around the world. Some places I never thought that I would be in, but you know, this company and drone technology has really provided me opportunities to see the world. As you can see at the top here, we are essentially a 2-part company. We have Global Air Media, which is mainly focused on providing commercial services with drones. We're going to go into some of those as well. And then we have the Global Air Drone Academy, which focuses just on our education and training. That is a nonprofit entity, and we like to, of course, do workshops around the world. So you can see some of our coaches that we have in various places. Coach Vic here that did a workshop at Harris Academy a few years ago. And we have been in the UK, of course. So these are some of the examples of some of the events that we have done. Croydon High School, Harris Academy, of course, last year, the Big Bang Festival, Sutton High Street. So hopefully some of you were able to experience that. And we do a lot of work also with STEM learning, trainer workshop that we've done with them as well. We have done a summer camp at the Redbridge Library. This is actually an opportunity for you all to actually come out and learn how to build and fly and actually take home your own drone. So I wanted to show you quickly how this summer camp goes. And we had a group of about 15 students last year that had an awesome time. So just wanted to show you so you can get an experience into how our summer camps work. All right, so obviously right now we are in a virtual mode, shall we call it, and we're doing a lot of our workshops virtually, but hopefully when things finally open up, we will be back into the libraries and hopefully maybe at your school as well. So if you're interested, definitely let us know. I wanted to let you know we have a free program going on online every Wednesday. So if you're interested in learning more and actually doing sessions like this, we have students that come in from all over the world, as you can see here, some of the call times we have in. But every Wednesday, feel free to sign up on our website. It's called the Virtual Drone Club, and you will get to join in with some amazing students all across the world. So quickly, we're going to cover today, we're going to go a bit over drone safety rules. We're going to learn about how drones are being used to fight the COVID-19 virus. And then we actually have a logo design competition, which we're going to tell you about. And you're actually going to have some lucky person on this call who's made it all the way to the end. You're going to get a chance to win yourself a drone camp in a box, which is a new initiative that we have going on. So I mentioned Global Air Media. This is just an example of one of our project shoots that we go on. You can see that we're very safety conscious. All right, so we wear vests when we're out. You can see back here in front of my partner, Austin, there is a takeoff pad right here. So every time you're flying a drone, you have to be aware of safety measures. So where are drones being used today? We've seen drones being used in a number of different industries. And for some reason okay, here we go. All right. So we have construction, using drones to map out certain areas of land to track progress. We have agricultural uses where you can use drones to plant tree seeds. You can use drones to spray your crops, of course, monitor your crops over time. One of our first ways to get into the drone industry was real estate. So we used to go out and shoot video and pictures and take pictures, for realtors who wanted to sell their property and wanted an innovative way to do that. If you could think about traditional ways of selling your home, you go out, you take a picture from the front or the sides of the home, but you're not really getting that perspective of what the neighborhood looks like, things like that. So this is actually what we call the low-hanging fruit to the industry. There's a lot of work in real estate if you're interested. Conservation, of course, being able to track everything from animals to erosion in the environment. There's so many applications. Delivery, which I'm sure you all have heard about. They've been doing a lot of delivery in the UK, especially when it comes to Amazon. Also medical deliveries, which we'll get a little bit into. And of course, filming. Filming is something that you may not, of course you're gonna think of first off, but other people like to think of commercial applications, but filming is near and dear to my heart. It covers the arts. Now we're talking about STEAM technology instead of just STEM, so science, technology, engineering, the arts, and math. So of course, drones essentially cover all of those bases. Quickly on the Drone Academy, this is just some of the things that we offer to some of our clients. Of course, our youth programming is our core part of what we do. That's how we really got started. So just going to take a little bit of drone safety rules for some of you that may already have drones, just so you are aware of some of the safety rules that we adhere to. Here in the United States, we have something called the Federal Aviation Administration. Essentially, they set the rules and guidelines for everything that's in the sky. So planes were, of course, there before drones. So they regulate planes at the aircraft, planes, and drones at this point. And of course, in the United Kingdom, you have the Civil Aviation Authority. So essentially, these are the police of the sky, all right? So if you ever need permission to fly somewhere or want to get a license, if you're in the UK, you would have to go through the Civil Aviation Authority. Now, when you're flying, there are a few key points to keep in mind. And I'll just touch on 4. There's obviously a lot more. And I would like to maybe get some questions about drone safety in general. If you have them, please ask. But essentially, we always say, keep your drone in a visual line of sight. We call this the LOS, your line of sight. All right. And quite simply, no sight, no flight. All right. If you can't see your drone, your signal can easily be messed up. You can, easily have your drone lost for whatever reason. So make sure you can always see your drone at all times. Typically, we have a rule that says in any country that you're in, 400 feet is the legal limit. But of course, that is equivalent to 120 meters. Even that is extremely high for just flying, a regular hobby drone. So I wouldn't even suggest going above maybe 200 to 250 feet. That's about 60 to 70 meters. That's definitely sufficient for your age group, unless you have a license to shoot something much bigger. Then I would say you can go higher than that. But just for safety reasons, I would stay below there. Always know where and where you cannot fly your drone. All right, privacy is a big issue. Security is a big issue. I'm sure everyone remembers here about the Gatwick Airport situation that happened. I believe that was a Christmas or 2 ago. So we always want to make sure that we are getting permission to fly. And then lastly, not flying at night. This may, of course, seem as common sense to most of you, but flying at night is definitely not allowed. First of all, it's very hard to see a drone at night, even if you have lights on it. But think about how difficult it is to see other structures. Trees, of course, are not lit up at night. So you're going to have a much more difficult time flying when you're doing that. So that's our 4 safety rules. I'm not sure, Fayon, did you have any questions about?
Oh, shall we? Yes, I've got some questions already. So thank you so much for your dynamic presentation so far. I mean, it's so exciting. We have a question. What's it like when you fly? I don't know who this is from, but what's it like when you fly a drone and look through the camera? Because I've got one, but it's quite cheap, this person says.
Okay. So yes, so basically your drone, depending on its capability, you can transmit the video directly from the drone to your phone if you're using a phone to fly, or your tablet. And these video, the video quality ranges. It really just depends on the quality of your drone. So most camera drones come with the ability to transmit if it's via Wi-Fi or Bluetooth. But you can also have a situation where we have something called FPV, first person view drone racing, which I'm sure some of you have seen before. And that involves you actually wearing goggles. And so as your drone is racing around the course, you can actually see what your drone is doing. It's pretty awesome.
Cool, cool, cool. And what's the coolest thing? Harsha Mata wants to know. What's the coolest thing you've done with your drone?
Wow, that's a good question. The coolest thing I've done with my drone is probably deliver an item. We were in Ethiopia. Actually, we were doing some trials for some medical delivery, and part of our proof of concept, we had to carry non-medical items. So we actually carried a pizza to kind of test out the weight and things like that. So that was pretty awesome. That's definitely one of the coolest things. And I would say the other thing is drone racing. Drone racing is by far a very, very fun activity.
Cool, cool, cool. People are already joining you on your YouTube channel. You've got some new subscribers.
Oh, awesome. Thank you very much.
Sebastian Secretary is saying, nice edit. Yeah, I agree with that. So Agastya is asking, I have a drone and I can fly it, but every time I do, it discharges after 10 to 15 minutes, even at 100%. Can you help me, and do you know why?
Sure. So that is very normal. All right. Don't. It's not you. It's not anything. It's the drone. So typically, when you have drones, this is one of the example of we call a DJI Tello drone. So when you have these small lithium-ion batteries, the battery life is typically small. All right. So even this drone, this gets a max of about 10 to 11 minutes. All right, for this drone. Some of the bigger drones, and I'll show you. Let me give you an example. We call this a quadcopter drone. All right, so even something like this, as big as this and professional grade drone, you're only going to see about a 25-minute flight time on this. All right, so flight times are generally low anyway. I would say we are very new in the industry. This is definitely technology that people are working on to extend the flight time, but that's just the normal kind of flight time. So what we encourage you to do is buy a few extra batteries so you can keep up in the air, and that's typically how we control that.
So thank you. Ronan Chandra wants to know, can we make a drone at home, and what would we need?
That is a very good question. So you can make some parts, but there are some parts that you will have to purchase. So for instance, if you wanted to 3D print the frame of the drone, or you wanted to, so this is like the outside area of the drone, you could explore 3D printing things like the propeller. It's actually pretty difficult to do that. You could also obviously use different material for a frame. I've seen even toothpicks being used, well, not toothpick, but a popsicle stick being used. But to make something like this, like the motor, is very, very difficult. It's not something that you can necessarily do at home. So you could build the outside, the framing part, but you would have to buy the motors and the flight controller, which controls how the drone moves. That's on the inside. Some of the electronic pieces that you can't necessarily make at home, you would have to buy online.
Okay, thank you. Padma Apana has a couple of questions. I'll put them together. Noticed that you had filmed some of the video by drone, so that's pretty cool. But also, is your camp in America only, or can you come to us?
Yeah, so the camp is in the UK, of course. We did one at the Redbridge Library last year. We were hoping to do a lot more this year, but of course we're in the situation that we're in. So we are doing online virtual camps. We have an initiative called Drone Camp in a Box, which I will tell you about as we announce our contest for today. But yes, we are adapting to the times, and as soon as we are able to get back to the UK, we will be there. We have a local partner, my friend Amir Chukta. He actually organizes some of our on-ground workshops. So definitely we will have an opportunity for you to participate in the UK. Sure.
Cool. There's a question here about how much drones cost, and I really feel that sort of depends on how big you want to go, how fast, how powerful.
Yeah. Yep. So yeah, a lot of that depends on what you're trying to do. So I could just give you some examples. I'll just bring my screen up, and then actually this would be a good segue back into the COVID-19 applications. But you can see here we have 4 different types of drones, starting from a quadcopter, which has 4 motors and 4 propellers. And then we have a hexacopter, which has 6 motors, 6 propellers, octocopter, and a fixed wing. Now, I would say starting on the low, quote unquote, low end, you could get a professional grade quadcopter for, as little as 500 pounds. And depending on how many, batteries you want, if you want a carrying case, all that obviously can add up. And as you go up, obviously these are more capable as you go up. So a hexacopter would most likely start around 2,000 to 3,000 pounds. An octocopter, I would say more like 7,000 to 8,000, because you're obviously able to do more with these type of drones. So you can spray. One of the things we like to point out is there's a payload on here on the bottom, so you can actually, and this doesn't have to be spray. This can be a larger camera. There are different type of sensors that you can use on the bottom of your drone. And then we have the fixed wing here, which is built for long distances, built for long range flights. Sometimes we see fixed wings as opposed to our multi-rotor drones here. We can see some fixed wings last sometimes for hours and sometimes days at a time. The military grade fixed wings can last that long. So of course, something like this, your price range will be, I would say 20,000 pounds and above. But of course, this is for professional grade. If you're looking to just get in as a hobby, you can get as little as 20, 30 pounds on Amazon right now. But just to kind of show you a little bit about how drones are being used to fight COVID-19, and we'll jump right back into the questions. So we've seen actually a few interesting uses. All right. And one of the uses that you may not even think of, so let me just go through the first 4 that we typically mentioned, and something I actually came across this past week, which is something really, really awesome. So we've seen the use of thermal cameras, and specifically when it comes to COVID-19, obviously we are trying to identify people who are sick, who have a fever. That's a clear indication that they need more attention. So now we're seeing drones that have thermal cameras attached to it to be able to do certain type of surveys. And how this actually works is they work in tandem with a nurse or doctor that's on ground. So you're able to actually approach that person and say, hey, we noticed that, you have elevated levels. Are you feeling okay? Can we, help you in any way? The next thing we've seen is the delivery of supplies, which I touched on briefly. Amazon has been doing this, but obviously when it comes to social distancing, as I like to say, physical distancing, not social distancing, but as it comes to applying those different things, we have to get supplies to people still, and we have to find innovative ways to drop those supplies. We've also seen aerial spray and disinfecting. This is particularly interesting because, and I have an asterisk here because we're still actually testing out that use case to see how effective it is, but it is an innovative way to use drones. And of course, public information and crowd monitoring. You can see here, this is a DJI Enterprise, Mavic Enterprise drone, and this is actually used to send out messages to people, to communities, to tell them where maybe they can't be, just maybe general safety rules. You can actually pre-program recordings So if you fly off to about, you know, one kilometer down the road and you need to let the community know something, you can let them know with this. And then the last thing I have here is the drone light show. You're probably thinking, how in the world is a drone light show going to help us fight COVID-19? I'm going to show you exactly how they did that. There's some really awesome stuff. I wish I knew which company this is. They are in Korea, but I just want to show you this, and we'll come right back.
예, 보시는 것처럼 비행 가능 상태에 대한 점검을 하는 절차를 밟고 있습니다. 코로나 바이러스를 예방할 수 있다라는 내용들의 메시지를 담고 있습니다. 보고 계십니다. 마스크를 쓴 두 사람이 거리 2m를 우린 하나 되어 이겼어. 감사의 마음을 담은 땡스 투유와 하트를 드리겠습니다.
All right, so some pretty innovative stuff. Who knew that they can send messages? Yeah.
That is so cool because I don't know if it translated over to America, but over here in the UK, we had children drawing rainbows and put up in all the windows and so many messages. Thank you, NHS. Thank you, key workers. So, yeah, that is awesome. And even on my road where I am, you know, there used to be a sign that said, you know, if you're driving over a certain amount, it'll tell you. Now it says, you know, wash your hands, stay alert. Thank you. So that's where drones could come in, I guess. Yeah.
Exactly. Yep.
Okay. Loads of questions before we finish in about 3 minutes.
Sure.
I'm going to combine some questions. So, Faiz Shakir is asking, do you think there will be drones with zero noise? And also, another question would be, what if you have a camera on your drone? Do you still need to have it in your sight? That's from Augustine Teal.
Yes. So as far as, I'll start with the camera sight. So if you can do either or. You don't necessarily have to have the goggles on. You could easily use a separate screen that's maybe on the side that you can reference. But the main thing is for you to see where your drone is. And if you're using goggles, it's not going to be in a scenario where you're doing an inspection or you're doing some type of survey. All right. The goggles are really specifically for racing. Because you're in a confined space. So anytime you're flying, you know, out in the open air, you definitely want to make sure that you don't have any goggles on and you're able to either see directly on your phone or from a second screen. That can definitely allow you to be safer at the end of the day, because it is about seeing, you know, where your drone is at all times. Apologies, the first question.
Yeah, with the camera thing. So if you can no longer see your drone and it's now out of your sight, because you've got a camera on it and you're monitoring it, say, from your mobile, is that okay? Or do you still need to physically be able to see?
Oh, yes, sorry. Yes, so physically, your eyes need to be on the drone. Right. So not where the camera is, or not. You can say, oh, I can still see it's clear. Your eyes need to physically be able to see the drone. If you cannot see your drone, then you're absolutely flying too far.
Brilliant. Thank you. So you answered that one. And it was about noise. Do you think noise will ever be limited on the drones?
So they are definitely working on that, just like they're working on the battery technology to have longer flights. Drones are quite noisy right now, and I'm sure that's what prompted the question. But yes, they are working on that. I would say DJI, they have actually put out specific propellers that cut down and reduce the noise. And, you know, I would suspect within the next, you know, year or two, they would have more propellers that can, you know, be quiet. I would say it's not too big of an issue just because in general, when it comes to privacy and security, you actually do want to be able to hear where the drone is. Yeah. So it's not, we're not hearing a huge movement to make them less noisy, but it is in progress. Yeah.
Combined questions. One from an anonymous person who's asking, what got you interested in flying drones? And Vikram Kohan is asking, how many drones have you made?
Good question. So what got me really into drones, I'll just tell a quick story. I was actually on a trip to Nigeria, which is where my father is from. And I was attending an event back in 2015. It was an inauguration for the governor of a state there. And I was sitting in the stadium just as a standby watcher. And I saw a huge drone being used to fly through the stadium. This was an octocopter drone. It was a huge, cinematic camera. And I just remember seeing that and I said, wow, like this is some amazing technology. And not only that, someone's being paid to operate, this drone. So once I did a lot of research for about 2 to 3 months, just looking at all the different applications of drone technology. I showed you some of the industries using it. That was my spark right then and there. I said, you know what, this is going to be huge. I want to be on the ground floor, and that's really how I got my start.
Brilliant. We're coming to the end, but I'm going to squeeze in some more questions.
Okay.
Somebody's asking, how much does the drone in the box cost? And Ryan Toe is asking, what do you do with the drones that other people build? Yes.
So the drone Camp in a Box, it is 125 US, which I believe is maybe around 140 or so pounds. I'll do the right math. Actually, I think it's a little less. I'll do the math on that. But yes, you can certainly go to our website. We are planning to open up our international shipping in the next week. So we will definitely make sure that we are able to get things to the UK. And then about I think someone asked how many drones I have personally built. I've probably built over 20 drones. I would say between 20 and 30 at this point. Some obviously are more experimental. You just want to see, how things work. And then with the drones that kids build during our class, typically they take the drones home. So we have a miniature drone that you can learn how to build. And throughout that week, you learn how to solder it, how to code it, how to program it. And then at the end of the week, you take it home. So we don't like to keep the work. We want you to take it home with you.
That's it. And when you're at home, because somebody was asking, you can fly things in your back garden, right?
Yeah, certainly. As long as you're safe and you have permission and enough space to do so, by all means, you can fly it in your backyard, definitely.
Okay, so we've got to think about wrapping up now, but more questions, a few, and that's it, we're done. These are all anonymous. Is there a way to increase the range of signal from your controller to the drone while flying? And how do people react when they see you delivering with a drone? All right.
Okay, sorry, the first one about the range?
Is there a way to increase the range of signal from your controller to the drone while flying?
Yes. There have signal boosters essentially that you can just purchase. DJI has. I wish I had an example here, but essentially, yes, it can significantly boost your range. But remember, there's always that rule of your line of sight. So it doesn't really do any good to invest in that if you're going to be flying further than you can see. So always practice precaution and safety before you do that. And the second question?
The second question, sorry, has disappeared. But what I can say is this is how we're going to wrap up.
Okay.
Drones, are they called drones because of the noise that they make? And a last one is a personal one, is how do people react when they see you delivering with a drone?
Yes. So it is definitely still a novel, still a new idea. If anything, we're seeing people more accepting of it. If you can remember in the beginning, there was some negativity, and still, when you see drones, when you hear about drones, some of the news stories are negative. So what we're trying to do is counter that narrative and make sure that people see drones in a good light. So wanted to quickly just wrap up and let you know we are giving away a free drone camp in a box. All right. So if you're interested in winning, just like we talked about today, there are some particular uses of drones when it comes to COVID-19. So what you're going to do is come up with your own drone company idea. All right. We're going to ask you to make a logo for that company or a flyer on Canva. And what you can do is submit that entry here to VDC. All right, this is for Virtual Drone Club at gadacademy.org. All right, and we will pick a winner from this group. So if you're interested in winning one, all we want you to do is submit your entry. You can also go to our website to sign up for the Virtual Drone Club so you can join us next Wednesday. And unfortunately, yes, we've run out of time, but I've had so much fun here today, and I look forward to speaking with you all again. All right.
Oh, wow. Before you go, people are asking for your contacts. So what's your Snapchat? What's your Twitter? What's your Instagram?
Yes. So let me just bring that up. I am on Instagram and Twitter. You can search my handle. Let's just bring this up. You can search my handle. It's Where is Eno? Screen. Type is Where's Eno? I'm on Twitter. I'm on Instagram as well. There should be a Twitter icon here. But if you also want to follow the Global Air Drone Academy, just type in GA Drone Academy and keep up to date with everything that we're doing.
Nice one. Wow. Again, could have spoken to you for so much longer. Thank you so much. And yes. Thank you so much for getting up early and sharing everything that you shared, and for giving away a drone in a box. This is so cool. So enjoy the rest of your day. Have breakfast.
Thank you. I'm going to do that right now. Thank you so much. I appreciate it. Have a nice day, everyone.
Take care of yourself.
Right. Thank you.
That is a massive thank you to Eno. Wow, it was just brilliant hearing from him. But I'd also like to thank all of our guests as well. Thank you for Sheila from Salters, who was here earlier teaching us how to make ice cream. Robert, of course, from Moonlander. I mean, wow, how fascinating was all of his information. Anthony as well, of course, from Gravity Industries. We all want a suit. Come on. So it has been brilliant to be your host today. I really enjoyed it. But don't forget to hook up with us on the 18th of July. Sutton Science Festival will be on your social media. The platform for us is Enjoy Sutton on Facebook. So you can find us there. And it's free. It's a mix of live and short films, activities for all different ages for it to enjoy. And the event is focusing on all things STEM. So you've got dinosaur talks, astronomy, astronomics, you've got engineering, you've got experiments, science, history, and so much more. So I really hope you've enjoyed today. Do get in contact with us at Enjoy Sutton if you have any questions that you want us to pass on to our speakers today, or hopefully you got their social medias, etc. So enjoy the rest of your day. Thank you for watching. Take care.